For the laboratory 14, which is the implementation of interpolation process, the aim of this laboratory was to verify the decimation of a given sequence. So, an upsampling, this is the process of inserting zero-valued samples between original samples to increasing the sample rate. You can call this as zero stuffing. So, to achieve the aim of this laboratory, we first define the upsampling factor and the input frequencies, which is F1 and F2. Next is represent that input sequence with F1 and F2. Third is performing the interpolation on the output on the input signal using the MATLAB command inter. Lastly is plotting the input and the output signal sequences. So there are a series of codes. This is the series of codes that need to be written, and what I said beforehand was the steps on doing that. So let's run this code. So the system will ask the user to enter a series of numbers, and the required for the upsampling is 5. The length of the input signal is 9. The frequency for first sinusoidal is 0.1. For the second sinusoidal is 0.3. So after entering these numbers, an output waveform will show up. So this is the input sequence and this is the output sequence. As you can see, it was almost the same. That it traces at 1.5 volt or 1.46 here. So there are both in the middle of 1 and 2, then goes down to almost 0, then goes up again to 1.5 or in the middle of 1.1 and 2, then goes down again. So this is the input sequence and this is the output sequence, and that is how we can verify the dissemination of a given sequence using the upsampling factor. The difference between the laboratory 13 and laboratory 14 is that in laboratory 13 we use a downsampling factor, and in this one we use a upsampling